In this video, we will be seeing the projection of a triangular lamina. Let's see what the question says. An equilateral triangle having 25 mm side is resting on one of its corner on HP. 9. Such that the surface is inclined at an angle of 60 degree to HP now. With respect to the VP, it is given that the edge opposite to the corner on which it is resting is inclined at an angle of 30 degree to the VP. Now, we have to be very careful that here, now the given equilateral triangle lamina is resting on HP on one of its corners. So, this is a corner resting problem. Now, to start with the solution, first we will be following the first angle projection, so that I will be drawing a horizontal line here. At this side, I will be naming it as X, and the other side I will be naming it as Y. Now, first I will be drawing the top view of the equilateral triangle which is resting on one of its corner. Now, to have the first one, I will be drawing a line having a length of 25 mm, which is as given in the problem, equilateral triangle of 25 mm. Now, to draw this one, we will be drawing the first line, this one. Next, with the help of your compass, measure 25 mm. And from each of this line segment, now I will be choosing this side now, cut an arc. Now from the other opposite end, with this as the center, 25 mm as the length, cut another arc here, so that we will be getting an intersection. Now I will be joining this intersection point to each of these ends of the line segment, so that we will be having the equilateral triangle. Now I will be naming this one, this end I will be naming it as small a, this as B, and this as C. Now to get the front view, I will be drawing the vertical projectors like this one, a thin line, and I will be indicating the arrows here. Now when these projectors intersect the XY line, since the triangular lamina is resting on HP, I will be getting the front view on the XY line itself. So I need to darken this, the front view here. Now this point from A, I will be getting this point as A dash, and from here I will be getting both the points, that is B dash and C dash. Now since the corner C will not be visible, I will be writing this C dash inside the bracket. Very simple. The corner which is not visible, you will be writing it inside the bracket. Now next we will be moving on to the second projection. Now it is given that with respect to HP, the corner of the triangular lamina is inclined at an angle of 60 degrees. So what I will be doing is, I will be marking any point. I will be drawing a reference line. This line should be 60 degree with respect to the HP. Now by measuring this length from the front view, I will be with the help of a compass. Now I will be cutting an arc on this particular inclined line. Now so that I will be making this lamina to be inclined at an angle of 60 degree with respect to the HP now. I will be darkening this portion of the length, that is A dash, B dash and C dash. Now what I will be doing is, I will be drawing vertical projectors from this front view now. I will be putting the arrows moving towards the downside. Now from the top view of this one, I will be drawing the horizontal projectors from each of these corners here. Now, where the horizontal projector from A and the vertical projector from A dash meets, I will be intersection point. This is from A and A dash. I will be putting a point here and naming this as A. Now, similarly from B, the horizontal from this thing, and the B dash from here, I will be getting this intersection here. I will be naming this point as B. Similarly, the vertical projector from C dash and the horizontal projector from C, I will be getting this point here, so that I will be naming this point as C. Now, my job is to connect A to B, next B to C, and last from C to A. This is my second top view. Now, last condition is the edge opposite to the corner on which the lamina is resting is at an angle of 30 degree with respect to the VP now. Now, what I should do is, now with respect to the VP, I will be drawing a reference line from here, and I will be drawing an inclined line. Now, this should be at an angle of 30 degree. So, this line is nothing but from the horizontal reference line, this is 30 degree. Now, next is what I will be doing is, we have the trying this side BC here, I will be measuring this from with help of a compass this length, and I will be transferring this length on this particular inclined line of 30 degree. So when I transfer this with help of a compass, I will be measuring this CB, so that I will be getting the length. This is BC and this is B. Now with the help of a compass, you will be getting much better scale, and this is a very freehand sketch. Now I will be measuring from C with the help of a compass. I will be measuring the distance of CA. With C as the center, I will be cutting an arc here. Now next I will be from B as the center, I will be measuring the length BA. From this B, I will be cutting an arc, so that I will be getting the intersection point. Now what I do is, I will be connecting this intersection to both C and B. I will be darkening this portion, so that this is nothing but A. Now finally what I will be doing, I will be drawing vertical projectors from each of these corners A, B and C. Now from here we have the B dash and C dash here. I will be drawing the horizontal projector. Now same thing, the vertical projector from A and the horizontal projector from A dash. Now this is the intersection point. I will be naming this as A dash. Similarly now the vertical projector from B and the horizontal projector from B dash. Now this is the intersection point. I will be naming this as B dash. Now I have the C here, the vertical projector from C and the horizontal projector from C dash. Now this will be my C dash. Now my job is to connect the A dash with B dash, B dash to C dash and C dash to A dash. Now this is my final front view of the triangular lamina. Thank you.